In 1998, a spacecraft left Earth with a simple mission: study the climate of Mars. It was called the Mars Climate Orbiter. It cost $327 million, and it never made it. On December 11, 1998, a Delta II rocket lifted the orbiter into space. For 9 months, it traveled silently across millions of kilometers, performing small trajectory correction maneuvers along the way. Everything appeared normal. Telemetry looked clean. Navigation seemed stable. No alarms, no dramatic failures, just numbers. On September 23, 1999, the spacecraft approached Mars. This was the critical moment: Mars orbit insertion. The engine would fire, the spacecraft would slow down, and it would slip neatly into orbit around the red planet. That was the plan. Instead of entering orbit at about 140 kilometers above the surface, the spacecraft descended to nearly 57 kilometers. At that altitude, the Martian atmosphere is thin, but not thin enough. The spacecraft either burned up from atmospheric stress, broke apart, or skipped off into deep space. Communication was lost permanently. $327 million gone. The cause was not an explosion, not sabotage, not hardware failure. It was something far quieter. One engineering team calculated thruster performance in pound-seconds, an imperial unit. Another team expected the data in Newton seconds, the metric equivalent. The numbers were never converted. The software accepted the values. The navigation system trusted the output. Each tiny miscalculation nudged the spacecraft slightly off course. Not enough to trigger panic, not enough to trigger alarms, just enough to compound over 9 months. By the time it reached Mars, the trajectory error was fatal. This was not just a unit conversion mistake. It was a systems engineering failure. Interface assumptions were not verified. Cross-team validation was incomplete. No automated check enforced unit consistency. The system trusted that inputs were correct, and that trust destroyed the mission. After the loss, NASA conducted a full investigation. The findings were blunt: communication breakdown, inadequate peer review, and a lack of end-to-end testing. From that point forward, stricter verification and validation processes were implemented across missions. Standardization became mandatory. Interface documentation became stricter. Independent review became non-negotiable. The Mars Climate Orbiter did not fail because engineers were incompetent. It failed because complex systems amplify small mismatches. A single unchecked assumption, multiplied across millions of kilometers, becomes catastrophic. In engineering, the most dangerous errors are not loud. They are quiet. They look correct. They pass through interfaces without resistance. And by the time reality exposes them, it is too late. $327 million lost to a unit mismatch. And a reminder that in complex systems, precision is not optional.